I'm Alex Soroyan. I'm CEO and co-founder of Netris. So Netris, we're based here in Santa Clara, California. Our customers are everywhere. So we also have team members in Europe, in India, and Sydney. We're focusing on network software for AI and infrastructure for AI and cloud infrastructure operators. We've been doing this since 2018. In 2018, AI wasn't as big as today, and most of our customers back then were tier 2, tier 3 cloud providers, private cloud operators, enterprise cloud operators. But some of the technologies that were being used for cloud providers in networking are also relevant and applicable to AI clouds. And with AI becoming very, very popular, and lots of organizations are now building infrastructure for hosting AI. NVIDIA networking is basically former Mellanox. They acquired Mellanox, they acquired Cumulus networks, and we've been working with Mellanox and Cumulus for a long time. And that way, when technologies created by Mellanox and Cumulus became basically the foundation for NVIDIA's networking, we appear to be kind of very much aligned with the stack. That created a good opportunity for us to work closer with NVIDIA and refine our technology for their AI infrastructure use cases, primarily around multi-tenancy and automation for cloud providers. I will tell more about this. So, although organizations that are running AI infrastructures that are coming from different verticals, we work with neo clouds, we work with infrastructure as a service providers, PaaS, with sovereign AI operators, with telcos. These organizations, they have different business models, but from our perspective, from networking, from technical perspective, what they are building is very similar from the stack perspective. And they all are heavily investing in infrastructure to run AI workloads, and AI workloads are very demanding. So the entire stack required to be improved, starting from power, cooling, compute hardware, compute software, networking hardware. Networking became way more complex in AI. So is networking software. Now, these AI infrastructures, they have many components. We focus on just one component, the networking. This is area where a lot of organizations are having the most challenges. One company cannot solve all these components, all these pieces of the puzzle. Even NVIDIA, being this amazing large organization, even them, they don't have all the components. That's why it creates opportunity for partners like us and others. So these GPUs that most organizations are willing to host and use are expensive. And because of that, the path to return of investment is through dynamically sharing these hardware resources with internal and external tenants. So that requires dynamic multi-tenancy, what we call. And because of that, networking becomes kind of complicated. But to understand the problem and to understand what how we're solving the problem, I want to do a little bit of kind of a simple history class here. So on this business school 101 kind of comparison, one axis is basically utilization of GPUs, and the other axis is basically safety. Now, why this matters is because when these organizations create AI infrastructures, they need to share hardware with internal tenants or external tenants. If they are cloud providers, obviously their business is to share with external tenants. And some of the earlier generations of kind of new wave of AI cloud operators were doing physical segregation. So basically, different clusters were separated from each other physically. Of course, that provides maximum security. There is no way to break in from one cluster into another one if they are physically separated, right? But the problem is that it takes a lot of time. And when you're building a cloud business, sometimes you want to isolate resources for 1 hour, 1 day, 1 week. And some manual method doesn't scale. And if it doesn't scale, these very expensive GPUs are basically idling. So what we've seen, historically, some of these operators, they started to share the network, basically build one infrastructure and manually configure the infrastructure, manually reconfigure the infrastructure to make it shareable across different tenants. Now, that does the job, yes, but the problem with that is it's manual. It takes time. It takes sometimes weeks to configure, hundreds of switches, and these AI infrastructures have lots of switches. And there's high risk of human error. You make one mistake while you are creating a new tenant and you misconfigure something, you can potentially break network for other tenants. And their training workloads may suffer and the customers will not be happy. So cloud providers realized that, obviously, and they started, automating things in-house. Now, in-house automation is very challenging. We've built a product for network automation. We know how challenging it is. It took us years to build, and we were focused on this one thing. But also the big problem with building automation in-house is that the organization that is building in-house automation, they learn from their own errors. Versus a specialized product is learning from the data coming from lots of customers. So these are obviously not great solutions, and they are risky, they are taking a lot of time, not a solution for a cloud provider. Now there's this other extreme, using Kubernetes and containers and namespaces to make isolation, which is very fast. That is API-driven, that is software-driven, it is fast. But the problem with that is that there's no isolation on a networking layer, so that creates a security problem. And, it takes just one container escape vulnerability to jeopardize the reputation of a cloud provider. Security is very important in AI because these customers are dealing with a data which is highly sensitive. Now, basically, AI infrastructure operators want something that provides a security level that is comparable to physical isolation, but is available at the software speed. So basically, some sort of, we call this cloud provider grade network automation software. This is what AI infrastructure operators need, and this is basically what Netris is focusing on. We're a software company that provides network automation, abstraction, and multi-tenancy software for those who are building AI and cloud infrastructures. Now, I like to explain this using this method of 3 pillars, which are kind of what are some critical pillars when you are building an AI infrastructure. So pillar 1 is this notion of VPC. Anyone who used any public cloud like AWS or anything knows what VPC is. It's the unit of isolation. And when AI infrastructure operator is building a cloud, you need the same abstraction model that works in the cloud. But you need, so these cloud providers, they built a lot of software in-house. They're not using any of available network automation techniques. They have built this in-house, right? But it took them many years. Like this first generation of providers, they had that time. The new generation of providers, they want to go live today. Like when we work with customers, they say, we want to go live this month. And it's like every month someone is going live. The competition is growing and new cloud providers want to deploy fast. So notion of VPC is critically important pillar. Networking, traditionally, everything in networking was tied to switch ports or in InfiniBand to GUIDs. Now, as a cloud provider, when you are defining your tenants, you don't want to deal with switch ports. Your customer-facing portal, which talks to your network automation backend, doesn't know what are switch ports. Your portal knows what servers are, what GPU servers are. So basically, when your customer-facing portal creates that backend request, it wants to say, hey, let's create a VPC and let's include node 1, node 2, node 3 in this VPC. You want to create a basic, you want to make a basic request and get all the details configured. So that's notion of VPC, that's pillar number 1. And by the way, any questions? Feel free to. Pillar number 2 is what we call cloud networking functions. See, with previous pillar allowed to create these isolated environments, isolate on Ethernet network, InfiniBand network, everywhere. But these are islands. Now, once you have that islands isolated, protected from other tenants, you have the need to let these islands to talk to internet, for example. Maybe you need to download a package from the internet. So you need something like an internet gateway to provide internet connectivity. If you're as a cloud provider, you're probably using a shared storage system, kind of very common for cloud providers, and you want you need constructs that allow to say, hey, my tenant number 1, my tenant maybe is tenant Coke, for example, wants to access storage. So let's create access to storage. Let's let this other tenant talk to storage, but without 2 tenants talking to each other. Internet gateway was another example. And if you're running inference workloads in this AI cluster, inference workloads are used by users in the internet, right? Think ChatGPT and their customers. So you need some sort of load balancer, which will take traffic from the internet and will balance between these different machines. Like in the cloud. In the cloud, inside your VPC, you can create internet gateways, NAT gateways, load balancers, elastic load balancers. And if you are a cloud provider yourself, you need methods to provide these constructs yourself. So pillar number 2 is cloud networking functions. And pillar number 3 is, look, these first 2 pillars are kind of nice and fancy. They provide cloud providers these constructs, which help them drive their business. But let's not forget that all this beautiful cloud is running on the physical network, and there are network engineers who need to take care of the network. They need to deploy the fabric, upgrade the fabric, downgrade the fabric, perform maintenance, learn if something is not good with the health of the fabric. So for that, you need a system that does your fabric management. Now, if these 3 critical systems are, different components, differently developed, or like, I don't know, coming from different vendors, what can happen? All these 3 components are trying to configure some of the same things. What can happen if 2 systems are trying to make changes in the same front-end network or in the same back-end network? Right? It creates a risk for logical disconnect, and it can create errors. Now, in our case, these 3 components are not really 3 components. It's a one product where the 3 components are tightly integrated into each other. They're using same database, same data structures, and there's no risk of creating conflicts. It's like when you drive a car and your wife is saying, take right, and GPS is saying, take left, but you go straight because you know that you're running out of gas and you need a gas station. So that's what Netris does for network automation for AI cloud operators. Now, so AI came from the HPC world, and InfiniBand networking was big in HPC. Even though there's a lot of developments in Ethernet, and we see a lot of Ethernet developments, a lot of Ethernet-based clusters. In our experience, based on what kind of customers we work with, approximately half of the customers are using InfiniBand in their backend fabric, and they are using Ethernet in their front-end fabric. Where for InfiniBand fabrics, we work through NVIDIA UFM controller. So like I explained in previous example, two systems should not edit the same system. We don't want to break our own rules. We don't want to go and touch the switches directly. So we talk to UFM, and UFM talks to InfiniBand switches. Versus on Ethernet side, Ethernet doesn't have something like UFM. And on Ethernet side, Netris is the fabric manager. On Ethernet, we manage the switches, we load agent on every switch, and that way we automate management of the switches. So from customer perspective, there is single pane of glass that takes care of entire stack, but behind the scenes, we manage Ethernet, and we manage InfiniBand through UFM.
Question? A question on the Ethernet management plane. Are you making an assumption that it's a multi-vendor Ethernet? Or is it a single vendor? Because some of those vendors do have fabric management. So would Netris be talking to one of the proprietary networking vendor fabric managers, or you're assuming multi-vendor?
Yeah, that's a great question. We support multiple vendors. As of today, we support NVIDIA, we support Dell, we support H-Core and Arista. Now, how we support? In these 4 cases, we are the fabric manager. NVIDIA H-Core doesn't have fabric manager. We are the fabric manager. We are NVIDIA certified for this job. For other vendors, there's no certification, but we've been doing this for a long time. We have live customers. It's not just theory. With some vendors, they also have fabric managers. Like if we take Arista, Arista has Cloud Vision, which is a very decent product. We do have some customers who use our technology in combination with Arista instead of Cloud Vision. Why? Because we bring, first of all, we bring this independence. So these customers may not only have Arista, they may have multiple vendors, right? And we bring some of this cloud functionality that are kind of more convenient for customers. So we also do a lot of Ethernet Ethernet clusters. So this case, it's a customer case study where we worked with Scott Data. Their AI cluster is using Ethernet both on backend and frontend networks. Backend network is based on NVIDIA's what NVIDIA calls Spectrum X. It is NVIDIA's Ethernet-based fabric. It's kind of alternative for InfiniBand. It is more scalable than InfiniBand, and it's Ethernet. It has some benefits. We can talk later. Front end is also Ethernet, and both fabrics. They don't have fabric manager other than Netris, so we manage the fabric. We also manage this layer. I will explain later. We have this cloud networking functionality layer we call SoftGate, which makes possible all that NAT, load balancing functions that switches do not provide. And customers get this single pane of glass for entire management. Similarly, we have customers. So for example, if we look into a solution for this customer use case, so TensorWave is running AMD-based cluster. They are one of AMD-based neoclouds. Their backend network is based on H-Core and Arista switches. So it's a mix, and the front end is based on H-Core switches. Any questions around this?
Not yet.
Sure. Is that so from an edge core perspective, what would be the network operating system on the edge core? Is that specifically Sonic or something else?
So that's a great question. For every switch, we integrate with one operating system that works the best on that particular vendor. So on edge core, that's Sonic. For Arista, that would be obviously EOS, and for NVIDIA, it would be Cumulus. Some vendors, they support multiple operating systems, but we do not integrate with all of them. We just pick one, which is, usually there is one that works the best with that vendor.